This is a small school podcast with a difference. We aim to showcase our school's future-oriented pillars of learning alongside the schools, movements and student leaders that inspire and invigorate our practice as educators. Our goal? Acting as agents of change in an educational world that must adapt to be ready for a fast-moving now and a fast-moving future. Each episode, we'll link up in thought leadership with excellent practitioners across all types of international schools around the world, learning from peers, sharing our best practices, and claiming our place in the wider world of educational innovation and whole child-centered learning. I'm Rachel Hovington, Head of School at Benjamin Franklin International School in Barcelona, and I am joined today by Martin Picard, a BFIS parent. Martin is a graduate of computer science and math from MIT and Harvard, and he is a veteran technical software innovator, company founder, and CEO. In his own words, he's had an exciting, rewarding, and fortuitous ride along the path of distributed computing and tech innovation in Silicon Valley. Martin now owns Can Picard, a small family vineyard farm just a 17-minute drive from Barcelona. He's founded and is CEO of the Alella Green Tech Charitable Foundation, or AGT. It's a green tech R&D center, product showcase, and activities community center. There are fruit trees, arable land, grazing land for farm animals, sheep, chickens, honeybees, and resources for green tech research and development. Their mission is to help everyone from young families and school children to Ph.D. students enjoy and learn about nature, sustainable agriculture, and investigate ideas about how technology can help us conserve resources and combat climate change. By fostering innovation, helping sustainable practices, and supporting products get traction, he hopes to make a difference. The work he does and the stories he tells fit perfectly with our Vision for Learning's stated goal of nurturing our students to be collaborative individuals connected to the world around them, who are empowered to design innovative solutions to complex problems to create a better world. Martin, welcome to the BFIS podcast. This is probably the most urban environment I've ever worked in, and yet it's nature that makes my heart sing. So bringing that to our students is super important to me in the context of problem solving. Can you tell our listeners a little bit about Alella Green Tech?
Well, okay. Thank you for inviting me, first of all. I do have two students at BFIS. One is 7 years old and one is 11. And so I'm seeing the world through their eyes. And I also try to stay a kid myself. And as a kid, the thing I found was the most fun was to have an idea and then see this idea take off, explode, make cool colors, whatever. So it was a sort of a project-based view of the world. And I became, later in life, a typical Silicon Valley engineer, typical Silicon Valley entrepreneur. Which is, to describe what a Silicon Valley entrepreneur is, and as you know, Silicon Valley is it's called Silicon Valley because it's a part of California which was the cradle of civilization when it comes to technology, starting from hardware and then quickly migrating to software and now even artificial intelligence. So it really is the place where innovation comes from, let's say, apart from all the more important things like the wheel and everything else. But as a Silicon Valley entrepreneur, you have a view that technology is this cool, fun thing that's going to benefit the world, and that's always been the case in Silicon Valley. They've always thought technology is something that is there to help. Problem is, if you look backwards, technology hasn't really benefited the world, because if you start from the age of industrialization, the motor car and the invention of everything after the steam engine hasn't really been beneficial to mankind if you look at the effects on planet Earth and the sustainability. Obviously, it's been fantastic for the quality of life, but this quality of life that we've all achieved has been at a great price to the Earth. And the sad thing for us parents is that it's our kids and grandkids that are going to pay what we and our ancestors have created. So as a Silicon Valley engineer, now that I'm retired, because having been involved in a company that went public and a couple of startups that were acquired, I got to the stage of life where, especially living in Spain, which it does not incentivize people to create businesses and be very capitalistic. It's a sort of an environment which tries to equalize, and so there's no real point moving to Spain and trying to create an empire for self-profit. This is not the right place to do it. So if you come to Spain, you come for quality of life reasons because you have a family here, in my case, because I met a woman from here. But also it's a really great time to think about giving back. So that's what happened with me. I come here and I'm giving back mode, and seeing I have kids, well, why not give back through the kids? And so it became very clear to me that there's only so much I can do at that stage of life I'm at, but my kids, and maybe even their kids, can do a hell of a lot more. So why not tool up the kids to be able to go forth as my ambassadors, and ambassadors to everybody else, to solve the problems that we have created for them and that they will need to confront as they mature and they go forth as adults. And when they have kids, they're going to be very worried about the state of living on this planet and the sustainability. And so what needs to be done to help kids confront this future? Well, we need to give them the tools, the knowledge, and the attitude to look at problems as opportunities for solutions. And a solution is really a project, so it's in my opinion. So everything comes from the opportunity to identify a problem and therefore work on a solution. And so a lot of kids ask me, you've created companies before, so how can I be an entrepreneur? How can I create my own company? And so if you want to create your own company, all you need to do is do something you love. Just do it. And then as you're doing it, ask yourself, is there something about this that doesn't quite work right? Is there something about this that's giving me a bit of a headache? And so maybe later you can focus on making it just a little bit better. And sometimes you find some really cool solutions to problems you find in the things you love to do. So basically it's just do what you love. So therefore, what we need to try to do is to get kids to love nature and to love gardening and to love just being out there, because by being out there they will identify things that are opportunities for them to solve problems, and these are the problems that we need to solve. So my philosophy is, can I influence 10,000 kids to love nature, but also to have the tools to implement micro solutions to micro problems or maybe even bigger problems. And once they are tooled up and they have this knowledge and they have this love for the environment and for solving problems, then they'll be in a position to go forth and do stuff that in my lifetime I won't be able to do. So that's what it is.
I have a question for you, which is not on the script, and maybe we can cut it out. But where does your interest in sustainability originate or come from? Was it because you come from Silicon Valley and there's an ecosystem there of talking about maybe some performative work, right, of trying to be planet friendly, but as we know, as you said, technology on the whole uses materials that are putting certain parts of the planet in danger. So what's the kind of relationship you have with sustainability, and where was that seeded in you?
I've always worked on things that have to do with checking the state of something, and then based on some parameters that you've set up, making a decision and then acting on it. And this has been my entire career. So monitoring and automation have been something I've always been interested in. And so I started with the predecessor to the internet, quite a ways. This was 1986, so it was way before the internet. But we were already we already identified that, hey, there's this information and it's stuck on these computers. Like if you make a booking in Chicago for a flight, you need to call your agent in Chicago to change your flight. And you queue up at the travel agency here in Barcelona, and if you want to change your mind, you go queue up at the travel agency again or try to get them on the phone. And this all changed when all of a sudden computers could share information, and I was lucky enough to be involved in the very first method for allowing information to flow from one computer to the other, which is called distributed database. And so from there, it was all about look at something, try to parameterize it, try to break it down into its basic components that you can actually analyze, and then try to see if one of these parameters is showing you that there's a problem that's going to happen, and try to act before it becomes a real problem. So preventative actions. And I've done this in several industries, and I've been lucky enough to where, I don't know why, but sometimes things start to either bother me or I find out about them just a couple of years maybe ahead of other people, and so I start working on it. So for example, 5 years ago I started working on water. That was 5 years ago. And with the flow of information, I started working on it quite early. And so when it came time to sell the company that I was working on, which was also information based here in Barcelona, I automatically had already other things that were very similar in nature, in the sense that there was something that needed to be measured, that you needed to know if the status was good or the status was, kind of like red alert, or was it just a kind of warning that the data was telling you, and then what were you going to do about it? And this came because in order to find a place to live near an international school, which at the time was on the coast in the Maresme, my wife Marga and I found we were looking for a little apartment or something that had a garden near the school, and from an agent showed us this fancy house which was way beyond our budget, but and I said, well, there's no way we're going to buy this place. But what about that tiny place there that's broken down? And he said, oh, well, that broken down house you can get for really cheap, and it has like some land next to it. I said, okay, let's go for that one. So it was just by luck that we bought the land that we saw from this terrace balcony of this fancy house. And when we moved into that house, which we lived in it a year just to get the feeling for it without doing any kind of renovation. And water, of course, was the number one thing. If you have a garden, if you want to have anything grow at all, you can either wait for the 35 days of rain that we have here in Spain, in which case, and as you know, in those 35 days, and I'm just guessing at the actual number, but you get pretty much the same amount of water that Belgium gets, except that they get it every 4 days, and we get it all in those 35. So the quantity of water is tremendous. And what does this water want to do? It wants to go to the ocean. So you just have this rushing water to the sea, which takes half of your topsoil with it. So if you have a garden, you're dealing with excessive water sometimes, and then no water the rest of the time. So water is immediately your problem. So since I immediately was given a problem, I immediately thought, cool, I can now solve it.
Yeah.
And so I've been working on monitoring water and finding ways for other people to monitor water, and it's very fascinating. It's really cool because it's to do with electronics. So, for example, I have a product. My old product was called Vreezy, Vacation Rentals Made Easy, and it was an automatic calendar system that calculated the prices for agencies that have lots and lots of apartments for rent, and it did lots of fancy things like automatically list your sites on all these websites and all this stuff. Very techy software. Yeah. And so that was called Vreezy. And so then I said, okay, well now I can make Wheezy, which is water made easy. Not vacation rentals made easy, but water made easy. And so I'm working on Wheezy, which is like, how can I make it really easy for people to manage water? So to manage water, you need to know how much water you're using, how much water you're receiving, and how much water you have in store, and then how much water your plants actually need. Because if we can change the way we water plants from time-based, like everybody has a little timer on their terrace, which at 6 p.m. Waters,
Yeah.
The most intelligent ones have a sensor that says, okay, if it's raining, don't water. That's already good. But it's not as good as something that knows whether or not the plant needs water. And if it does need water, what percentage of the maximum water that you could give it, should I give it?
Right.
And so this watering algorithm is an example of something that I give to my students when they come visiting, and we'll talk about it maybe later, but I've set up like shacks and bungalows and tents in the woods, and so I have students from all over the world come, and I give them I either say, well, come with your Ph.D. project and I'll help you work on it, or if you don't have a project, I'll give you one. I've had students from all around the world come, and one of the favorite projects is, can we find a new way of watering? And it's very simple. You have a microcontroller, a little computer that anyone can program, and the programming can be with block programming such as Scratch, and it can be with a object-oriented language such as JavaScript. So depending on the age, any kid can do this. And so I said, okay, here's a sunflower seed. It can grow 6 meters high if it's really, really happy. If it's not that happy, it'll only grow 1 meter high. So let's see. how you can and it's going to happen in 3 months or 4 months, so it's quite fast. And so the student can come up with an algorithm for watering, and it can be very sophisticated, like a proxy index of all sorts of amazing parameters, or it can be very, very simple, like I have these two little metal sticks in the ground, and if there's any kind of transmission of current from one side to the other, then there must be some moisture in the water, and if there's no conductivity, that means there's no moisture. So it's yes, no, but it's anyone can do it. And so from there, you can really come up with some amazing Ph.D. student could solve the watering problem, and we could all, instead of watering all of our plants at 6 p.m., it could be just very, very gentle, exactly based on what the plant needs.
Yeah. What a great system, given the water issues that we have in this region, right? We have had extreme water problems. The last summer, there was no public water. There were no showers at the beaches here in Barcelona. This is really, really current. So I get the question I asked you about where the sustainability desire to work in this field comes from. I don't know if it was already instilled in you or if it was something that you're just ahead of us because you're voraciously reading and researching. You knew 5 years ago that this was going to become one of the world's biggest issues, but it seems like you're driven by...
Well, I arrived in Barcelona on a little sailboat, which I sailed from Australia. When I left Silicon Valley, the company I was working for had done very, very well, and they said, here's a bonus, buy yourself a house. And I said, well, I don't want to buy a house because I've seen all these, I'm from Rome, so I've seen all these sad-looking Italian immigrants, and they're all talking about the old country. So I don't want to buy a house and be in America dreaming about Italy. I'll just buy a boat, and then when it's time, I'll just sail back to Italy. So I tried to sail back to Italy, and I actually did sail back to Italy. And then the gas station that I was supposed to fuel up after 5 or 6 years of navigation and all these adventures, and I finally got to Italy. The gas station hadn't been dredged, so the boat actually fell on its side because it didn't fit, and I got really frustrated at Rome, and I said, if I can't even take gas, and it's November and it's cold, and here I am half sinking in the Tiber River, I'm just going to go somewhere else. So I just headed west. I just sailed west. I sailed west, and I could choose, as you sail closer and closer to the other side of the Mediterranean, you have Marseille on the right, and you have Barcelona on the left. And I happened to speak French, and I spoke no Spanish, so I said, well, you should always pick the more challenging of two options, so I'll go to Barcelona, because I already know about France. So I ended up in Barcelona. But the reason I brought this up is you asked about the water sensitivity. Well, when you're sailing around the world, and the first time I did it was from California to Australia, I think I had 400 liters. And I was at sea for over 30 days by myself. Well, actually, the 30 days I was with a companion. But the two of us had 400 liters of water. And so we actually took showers with an emulsifier. You spray the misty into the air, and then you sort of like wipe yourself down with the moist air. Because I couldn't afford taking a shower that would use a liter of water. And so I was very sensitive to water. And so that carried on.
We are increasingly putting design thinking into our curriculum. So it's not just in a subject where some kids can take it, it's now all kids can take it. That it starts to become infused in interdisciplinary projects between science and design, between math and design, between individuals and societies, or history and geography, economics and design. And that's the NYP, that's the curriculum we're moving towards. So this sort of failing forward and prototyping our ideas, this is what you're talking about. One of the things I haven't wanted to do is have our kids parachute in somewhere, learn something for a few hours, and then come out and not be able to apply and move forward with it. So what you're talking about, PhD students that have a lot of time to prototype their ideas, to fail forward, to go back to the drawing board, to develop ideas. How do you think we can create that in a school environment when we're so constrained by all of these boxes and bells and so forth? Okay, yeah.
So I have some strong thoughts about that based on trial and error. When students come to me, they come for a couple of months. And they come and then they leave. So if they leave and they take their knowledge with them, those couple of months that they've been productive and learning really was great for them, but not great for the continuity of the project. And maybe it doesn't even benefit the local community or even the world, because it's just completely dependent on how they go forward and what they do afterwards. So instead, what I do is I have students work on a project and document their work continuously, and when they leave all of their body of research, all of their future to-do steps and notes for the next person. And this can be tuned for a school, because whereas in my environment, a student is simply leaving the work and for the next one, which could be someone of their own level or higher level. At the school level, you could have it across different skill sets and different ages, because if you break down a project into steps, some of these steps can be done by a certain age group, and certain other steps can be done by a different age group. But there could be an interconnection between the projects, and so the 7-year-old could work on, for example, coring. They could go and take samples of the soil using a tool. Then they could put it in a glass of water and add and leave it for several days and shake it up and leave it for a few days and see how much silt and how much sand and how much clay is in the glass. And then they could leave instructions how to do this, which could be, or the next steps that they see in the process. For example, to extract the clay, they could do a little bit of research. To extract the clay, we just need to take the top bit or the bottom bit, whatever, and they could leave the body of work they've done, which is the actual coring. Where is the good soil? Where is the soil with the soil where there's lots of clay? And they leave that for the next age group, which could be maybe the 10-year-olds, which are a little bit stronger, and they're actually going to extract the clay. So they're benefiting from the work done by the 7-year-olds, and now they're going to do the little bit of the muscle work of extracting the clay. But extracting the clay also requires some science. So they're going to do the research, and then they're going to leave the to-do list for the next step, which could be researching on how to build a wattle and daub house, which is a twigs and mud house, which we at our farm we actually have people living in very happily, because it's such a efficient abode, because it's several degrees cooler in the summer and several degrees warmer in the winter. Mm-hmm. And it's made out of twigs and mud. What more could you ask? And we've had, and it was built by 10 or 15 kids of all ages, and down to 4 years old. They were just all throwing mud at twigs, and it worked out great. So that was just an example of how you take a project and you break it down, and with the guidance of the BFI teachers that are so engaged and they're several steps ahead, it can be very easy to create projects that span time but also span skill sets. And then you just need sometimes you can also break it down to where things can be done in a classroom and then deployed in the real world. Mm-hmm. So for example, we're building a water wheel, which is going to be 4 meters high and make electricity. But this water wheel has some unknowns, which even the best researchers have trouble figuring out, which is like, what is the most efficient angle of the buckets that are the water comes shooting down and it gets stuck in the water wheel, and the weight of the water makes the water turn. Mm-hmm. Okay, that's one way of doing it. It's called a Pelton wheel. And another one could be an impact, where the force of the rushing water hits the wheel and makes it turn. Mm-hmm. Well, the two are, interrelated, but there's all this science, like Bernoulli's equations and lots of stuff if you really wanted to figure it all out. But instead, you could do it by trial and error, which engineers like a lot. And trial and error, what better way of doing it but to 3D print a tiny model of the wheel? And so that you don't do that on a farm, you do that in a classroom. So as an example, a project like that is born in the classroom and then gets deployed in the field. And it's a great thing. And it can be over any age, because everybody can do a little bit piece of 3D design and 3D printing with all sorts of, you can go from really easy 3D programs to much more sophisticated ones. And then the printing everyone enjoys. And then to see it working in the classroom, which of course you can do with a small container full of water. But then it's very easy to put an ammeter or a voltmeter and see how much voltage you're producing, and then to turn that into the real thing. Well, it's just scaling. And so the electronics club could figure out, okay, if I've created X amount of power here. If I scale it up by 100 times, will the power I've created scale up 100 times? Or is there some formula I need to know where it's, so that's very interesting, and that can be quite technical, or it can be simply hands-on. All of these projects are really available and easy. And sometimes I run out of ideas. Like I had these really brilliant BFIS students this summer. I had 4 of them, and what I did is I assigned them to I had 3 Harvard students visiting. One was a mechanical engineering student, one was a computer science engineer, one was a bit of a versatile finance, but he was also doing lots of other things. And so I gave each of these students their own assistant, which was a BFI student.
Mm-hmm.
And actually it worked the other way sometimes, because a couple of the BFI students had actually more applicable tech knowledge than the actual Harvard student, because at Harvard you end up, which is my alma mater, so I know, you end up doing all this really boring theoretical research, and it's actually more Bachelor of Arts, it's like you study physics, but you don't really study engineering. And so someone that's been really hands-on and knows how to hack microcontrollers
Mm-hmm.
is actually more ready to work on one of my projects than someone that happens to know all the formulas for Laplace's equations or Maxwell's equations. It's not going to get you too far if you just want to figure out if a wheel is making a lot of electricity. So it worked both ways. The high school student actually was helping the college student just as much.
There's that element of creativity and a confidence to have an idea, even if it's a crazy idea, that we want to instill in our kids. And I think sometimes we experience them as feeling like they need to know it, right? That it wouldn't be a problem and we wouldn't have them on it if we already knew how to solve it, or they already knew how to solve it. So that them coming out and working on real world problems is part of what we're trying to infuse in what we're doing for all kids. When it comes to a whole class that are working on something, what have you experienced? Some of our classes have been out there this year to meet you and see what's going on farm.
So Alella Green Tech is a foundation, and so its role is to give back by tooling kids up for the future.
Mm-hmm.
And so when kids come, it's also limited to the stuff I know about. There's a lot of stuff I don't know about. Like, for example, the creating these amazing photovoltaic panels. I only learned that from Tom Warburton day before yesterday when he explained it to me. But now it's like, whoa, we need to build that into the curriculum here at the things that we offer.
And for our listeners, Tom Wolverton is one of our new science teachers who's just joined us.
Who in the past has been doing a brilliant project on creating solar energy, not from silicon-based solar panels, but from the difference in properties for different types of, just to say, play it simply, because I don't really understand. Let's just say you have 2 different types of paints and you put them next to each other, and there's some kind of, they react differently to the sunlight, and you're going to get a little bit of a current effect or a voltaic effect between them, something like that. Mm-hmm. But the idea is amazing, because you could take your car and paint it, and you'd have a battery cell, So these kind of things you learn by doing. Actually, I should ask you to tell me the question again, because I can't remember what you asked me.
What have some of our kids been seeing? So you've just shared with us what Tom came up to visit you this week. He's one of our teachers, but one of our I think it was one of our 6th or 7th grade classes or 8th grade classes were up there with you recently with Julia Halverton, who's also one of our science teachers. Yes.
So I've had several BFIS groups. So the foundation caters to school field trips, and we divide it up into the morning session being several different stations. So we divide the kids up into different groups depending on how many there are, and they go and see different things. And then I usually meet with the science teacher before and try to match it to the curriculum of the school, or at least to what the science teacher feels is important. And because there's so much that could be shown, so try to focus it on something that the kid's gonna recognize as something that they've just studied or that they know about, So it's very fun. So, for example, there's a bunch of abandoned wells. And we take kids to and the young students and show them a 100-year-old well that is no longer active. There's no water in it. It's totally dry, because it was built at a time when groundwater was really plentiful. When there was so much green, that it created its own ecosystem. There was more rain, and the earth itself stores water. So underneath the plants, there's this reservoir of water, which is not a pool of water, it's just in the ground. And just like if you had a wet tissue, the water actually wants to seep out. And if you do it right, you will actually guide that water, or just by luck, if you put the well in the right place and it's only 10 meters deep, it will be full of water. And that is going away. The world is drying up, and those ground wells, which are called dug wells because someone actually dug them, and they put beautiful little bricks and they look fantastic. But these dug wells are dying. And so we show kids this, and it really emphasizes what's happening with the world, because you have this sad looking dry well and no water. And they're looking around and they see arid landscape. They say, well, of course this well is dry because there's no water to be seen. So believe it or not, when the Romans came 4,000 years ago and conquered Hispanica, or whatever they used to call it, and they took away all the oak trees to build their ships, which they by the way, the Romans built really crappy seagoing ships because they were used to coastal navigation, and when they tried to cross from Barcelona to Rome, that most of them sunk near Ibiza, and there's a friend of mine that knows where all the amphoras are. So another project would be to go collect amphoras.
Go diving.
But all these poor oak trees are at the bottom of the sea because they were pillaged for these ships that weren't well designed in the first place, and it left deforestation. So the land that is part of Alella Green Tech is this quite a steep incline, and it's void of most trees, and it's quite arid, right next to a woods, which has regrown, but it's mostly pine. The idea is to show the kids the dry well, and then just nearby there's the same well that just by coincidence still gets a little bit of groundwater, and so I can show them the old ancient well actually working. And then I show them a well that is not 20 meters deep, it's 300 meters deep. It is Empire State Building deep, or more. I don't actually know how tall the Empire State Building is, and that thing is full of water. And when I turn it on, water shoots up into the sky, and so it makes it all real for people. But then you also have to talk about, well, that water we're taking from the water table. It's irreplaceable. It's prehistoric water, or maybe it's water that's coming from 100 kilometers away, or from the mountains in Andorra. We don't know, but it's just water that we really shouldn't be taking without replenishing. So how can we replenish the table? How can we take water when we need it but put it back? And so that leads to all sorts of neat experiments, which have to do with porosity of soil and distributed water collection. When you have rain, don't let the rain rush off to the sea, but have it stay on your land, greenifying your land, and then passing the runoff to the next land down below. And so all of these kind of things. And so the kids see wells, they see also erosion, because when these significant water events happen, the water rushes to the sea, taking a lot of the topsoil with it, which is a really disaster, because as you know, the life is in the last 20-30 centimeters of your land. The life, all the worms and all the biogenome that you really want is there. And if the rain event takes it down, you've lost your life. So what do? Well, there's these really easy techniques that are really ancient. When you see a crevice, you can fill it up with twigs and a few other things, and before you know it, the next time sand rushes by, it's going to be trapped by the twigs, and it's going to create like a beaver dam. And sooner or later, you're going to have that water's not going to rush that way anymore. And then you have to give the water, you have to think and say, okay, but where's the water going to go? Like, it's just not going to go this way, but it's going to dig away that way. And it might dig under my house. It might be worse. So you have to say, okay, let's guide the water. And so before you know it, just by fixing erosion in one place, it forces you to actually find a bigger solution for the utilization of the rainwater. That's one thing we do. And then we also show all the smart sensors, how you can collect information from parameters and very easily lead it to very simple Arduino-like microcontrollers that can give you data. You can store the data. When people ask me for how is water on my land, I can show them 3 years of data about how water is on my land. and I can look at it and look at trends instantaneously. I can see whether or not what effect climate change is having on my land.
Yeah.
And kids could do this in a simulated way in the classroom using the same tools. So we show them that. But we also show them fun things like where we have a trek to the beehives, which we stayed kind of far away, but it's really interesting to see that we built a fence around the beehives, which is ridiculous, like 2 meters high. And so why did you build a fence around the beehives? Well, the town council says it's a law. I said, well, what's the thinking behind the town council? It's like, well, they say that the bees are going to arrive at the fence and then they're going to have to fly up 2 meters. And that's going to protect humans from getting stung. So, okay, sometimes you just have to understand that bureaucracy is part of the world.
We know quite well.
So there's also some stuff to learn, and and then we show them sheep shearing, and robotics. We have a working gardening robot, which is very interesting. It mounts different tools. There's lots of projects in the future for smart BFIS kids building better tools that the robot picks up with 2 little magnets, and the robot has available water, air, and electricity. So you can build a vacuum cleaner to suck up seeds and shoot them out, or you can build a terminator for weeds, which is a spinning blade. All these things are classroom projects which then can get deployed.
Yeah. And you've already met and interacted with the robotics lead here.
Yeah.
So what kind of ideas were coming out of that discussion? I know that you've mentioned a couple there, but I know there were more ideas being seeded.
Well, I have a field that's quite large. It's like as big as a football field, like a big football field. And I'm working with some people from industry to set up, maybe divide it up into 7 strips, and have autonomous robots, which are, as you know, robots that are independent for energy and have a task to do, and they're very smart about how they can do that task. They can take information from the soil, they can receive information from the satellites, and so the kids, when they see these this area, it's available to them, and Mr. Farmer, who leads the robotics effort, right now they're very focused on the competition that they're going to have, and I'm very happy that they're doing that, because I've always used to watch the robot wars on TV, where you build these cool robots that can take each other out like boxers, but that technology is completely applicable later to retooling it and doing something extremely useful. So we've decided that once the competition is behind them, they can take that robot and rework it to do some really interesting task. And I have a friend here who has a lot of experience with robotics. He's been the CTO, Chief Technical Officer of a couple of robotics companies. He's just started a new one, and I've promised him one strip that he really wants, where he can test his robots out, and I've suggested that we create a BFIS Industry Day, where I bring 3 or 4 people from the robotics industry to talk to the kids about what are the problems that robots are solving, not so much the technical aspects, because that changes, but the problems ahead of us are going to be the problems ahead of us for quite a while. So to have the students think in terms of what are the problems that need to be solved, and therefore what are the solutions that they can let fester in their mind over the next few years, and then to come and bring their robot and give it a go in a real environment.
It's so great to talk to a parent who's seeing all the positives in AI, because I often get emails that say, what are you going to do about this horrible thing that's going to affect our kids, or our kids are too connected to technology, and of course there's a balance there. But the idea that our kids are using AI, using robotics, what is, just for our listeners to understand, when that robot is being retooled and it is learning from satellites about its location and adapting to the conditions, can you just give folks a little idea about what that world is that our students are connecting with?
Basically, a machine works by receiving information, processing that information, and making a decision, which could be moving forward, moving backwards, deploying a tool. And AI is very similar. AI is checking a database of information, coming with a guess for what to do next, and then checking whether that guess was a good one or a bad one, and then going back and modifying its algorithm to get a better result the next time. Everything is about information and access to information, and the next thing is it's about intent. Information in itself is good. Algorithms can be evil or beneficial. So we unfortunately, for every 1,000 people doing something beneficial, there could be X number of people trying to do something bad, and that's just how the world is. So moving forward is about creating all this fantastic stuff that we want to happen and not stopping it from happening, because that would be like saying we're not going to allow the wheel to exist because some thieves might rob a bank and run away with a car that has wheels, so we want to have only square wheels so that the bad guys can't get away, you know? But, every technology, no matter what you do, no matter, even if you stop it, some other technology is still always going to be used for evil. So what happens is, what do we need to do? We need to train our kids to become guardians of the right way forward. So we want the smartest person in the room to be a good person, not to be a bad person. If the kid gets away with something bad too often, they begin to think that the right way forward is not the good way forward. So I think being strict at the beginning is really important. But the strictness doesn't come from limiting technology. It comes from the reward process, for making it much more cost efficient for people to do good stuff than to do bad stuff. Now, I always ask myself, why would someone go around breaking into houses these days that there's nothing to rob in a house? I've been broken into 3 times, and the most I ever got away with was an old iPad that was at least 8 years old. I got nothing out of all their effort. I had videos of them sneaking underneath the beams of the sensors, and all this effort they went to. Got nothing out of it, and they must know, but they keep coming back. I mean, that person is so talented because they're so good at what they do. Well, I'm sure there's some other profession, for example, cleaning windows at the top of skyscrapers, where would they be paid a hell of a lot more than they got from my iPad. So I think actually it's part of the education. The solution in the long term is not stopping technology, it's improving our educational process to where people don't want to be evil. Now, obviously, you'll never solve it, and that's very idealistic for me to say, but it is part of the solution. And the other thing is to teach the good guys, and when I say guys, it's a guys
gender inclusive.
It's a
yes.
gender neutral statement. I hope it's clear these days that guys has become meaning both men and women, because it's just easier to say guys and gals. But yeah, so the good guys have to be the best people in the room, and they have to have the tools available to keep us safe. And then there's tons of things they can do. Technology can keep us safe. So I'll give you an example from my own history. When I got to Harvard, it was 1982, and I saw a whole room of computers. I'd never seen that before in my life, because this was 1982. So the IBM PC was invented in 1975 or something, and so colleges didn't have PCs, but they did have terminals where you had this huge mainframe, and it went around serving all the terminals. So the terminal got half a second of time. So you type a character, it goes to the server says, oh, that's an A, I'll print an A on their screen. That's how it works. And so time sharing on a computer. So I thought, well, this is really, really cool. And I see people using passwords to get into these computers. I said, oh, okay, that's really cool. So I wrote a little program to look like a login screen. And I put it on the big server, and it displayed it on everyone's terminal. So within a few hours, I had everyone's password. So I would say I think I was the original hacker. I'm willing to listen to someone else that has a pre-1986 hacking incident, and then we can compare. So then what did I do with this data? Well, I was 18, so I wrote. They had internal email at the time, and so I wrote emails from this girl to this guy, from this guy to this girl, and I thought I was doing a prank, making them meet each other, and the prank worked because they got married. so, so, so that's what I did with the technology. It wasn't particularly bad.
But it could have been if you hadn't been educated in the right way. Yeah.
A little bit later, I had a girlfriend that wasn't doing very well in her computer science introductory class. So I wrote a little daemon, which is a program that runs by itself. It's not attached to anyone's computer. It just lives in the ether. And it went around looking for the solutions to the problems that she was working on. And then it would like take X% that I could code of the solution. And so she could get these random words that could help her with the thing. And there was this Ph.D. student called Mike Yampol, who became head of Merrill Lynch security. He was doing his Ph.D. and Harry Lewis, the head of computer science at Harvard, said to him, I think we have someone sneaking around our network. Can you do something about it? He said, right, no problem. I'm going to write a computer program that's going to look for demons that are accessing information in this area. And this is 1986. This is way before the word hacking had been invented. Mm-hmm. And so, I don't know that for a fact, but I think so. And so what did I do? Well, I saw that there was this demon accessing my demon, so I wrote a daemon to access it. I wrote a program to check for people looking at my program. And what did he do? He wrote a program looking for programs that were checking for his program. And we went to several depths, iterated, and in the end, well, he was a PhD student and I was a college student, so he won. So I think there was a time where I was brought into the office and they said, Martin, you have violated code, you are suspended from Harvard, don't say a word. Okay, you're not suspended anymore. Do you want a summer job?
This is why I love that our kids can be in touch with you, and I know we've got to be conscious of your time because you've got another meeting coming up. But just having you be part of the community, be engaged, be part of what we do here is so wonderful for the kids to have this real life, real world perspective. But also, you're a part of internet and computing history in many ways, and I think that's so cool for our students to be able to access firsthand through their teachers, through being able to meet you as interns. So I just really want to thank you for that engagement, because that's part of the community engagement we want to model, and I think it's working really, really well with projects such as yours. So thank you.
That's all good, great fun.
Martin, can I ask you one more question? I'm head of school. I'm 50. I've grown up in a model. I've never worked in industry. My degree is originally in applied and environmental geology. I then sort of retooled, honestly, because I fell in love with somebody and ended up in the city and didn't know what to do for that year. And ended up doing a PGC, loved working with young people. What's one piece of advice that you would give to me as a head of school?
Well, I mean, focusing on the school aspects, I think, as we said before, it's all about engagement of the kids. So kids just get bored so easily, and so it's finding ways for them to feel super engaged by what they do, and then you have had the time, and you're a professional, and so you're in a really good situation to look into kid motivation, because it's as soon as you put a point system. If I, like today in the car, I was driving the kids to school, and I said, hey guys, we're gonna have a competition, and that woke them up much more than if I had said, guys, I want to talk to you or something, all of a sudden. And so I think it's looking at education and looking for opportunities where you can bring ways to get the kids more engaged and make every subject to be this super cool thing they want to do because some kid reason, and that's the difficult thing. And then what are the attention spans, and to not have subjects that are 45 minutes, half an hour. They should only be as long as the kids are interested. And so it's just like watering. If you water your plants for an hour a day, well, you could have been overwatering or underwatering. But if you water the plants as much as the plants want water, and so maybe knowledge is something that is acquired when there's a certain receptiveness to them. And so I think there's a lot of challenges that you could address, which could be quite groundbreaking, quite disruptive. I don't know. I'm just someone that is taught to look at stuff and say, hey, what about this, And half of what I say is really dumb. The way I know if I'm onto a good idea is I ask my wife, and she says, that's a really dumb idea, and then I know it's a good idea. Because you don't want to work on something that everybody thinks is a good idea, because what's the lifetime time of that. In 6 months, everyone's going to know it. Everyone's going to have thought of it too. You want to go for ideas where everyone thinks it's a bad idea, because that is the idea that has wings.
Martin, thank you for being with us today. I am just unashamedly idealistic, and I've loved listening to you because there's a piece of you that exudes that.
Thank you. I think it's all going to be a lot of fun going forward. We can collectively bring the kids to where they're super engaged, super motivated, and also from my perspective, super tooled up. What else? What can they not do?
Simply, I am super excited about the future of learning at BFIS as our teams collaborate with Martin at Alella Green Tech. I hope you enjoyed this episode. Check out Martin's website that we have posted underneath this episode. Join one of his events. His team organises fun, educational and delicious events and activities for the local community and visitors from around the world. Their events are a perfect combination of education and entertainment. They allow individuals to participate in a range of exciting activities, including introductory robotics demonstrations, gardening with their innovative gardening robot, meeting newborn lambs, and playing football on their grass field. They offer a range of culinary options, including the chance to roll your own pizza or enjoy an authentic Argentine barbecue. Their mission is to get you out in nature, experiencing new things, and inspiring you to join the fight to save our planet. Join us next time as we explore more future of learning topics that directly impact BFIS children and their families.